Welcome children, welcome to Refresh Concepts with me Dinesh Modi. Let's inch further with the next chapter. The next chapter is Remainder and Factor Theorem. Now children, before I start off with this particular chapter, we have studied in our lower classes what? That how to find out remainder. Say for example, very much lower classes if I have to go, say class 3, class 4. If our teacher said that what if 13 gets divided by 5? So we have performed 13 divided by 5, 5 2s are 10 and the remainder is 3. So after performing actual division, we got to know that the remainder is 3, right? Likewise, if I have a polynomial which is getting divided by a monomial or a binomial, then with the help of actual division, also we can get the remainder. At the same time, via synthetic division also, the other method is, one is actual division, the other method is synthetic division. So with the help of synthetic division also I can get the remainder. Those who are not aware about actual division, I have given my videos first. I have given synthetic method also. So division of polynomial takes place by actual division, by synthetic division. Those who have not gone for it, please go for it. I have also mentioned both the divisions in my videos. Then question arises that either I go by actual division or synthetic division. Then what is going to happen? In actual division or synthetic division, along with the remainder, I shall get quotient also. So that means, say for example, a dividend is getting divided by a divisor. We get quotient also, we get remainder also. In actual division as well as in synthetic division. What if I want direct remainder and I don't want quotient? When a polynomial is getting divided by a binomial or a monomial, but here we are going to work out with binomial. What if I don't want the quotient and I want only the remainder, and that too directly without solving it by actual division or by synthetic division? Then what we should go with? Answer is remainder theorem. The name of the chapter is Remainder and Factor. We are going to study both the theorem. One is remainder theorem, other being factor theorem. Right now we are focusing on remainder theorem. So what is remainder theorem helping us? Remainder theorem helps us to get the remainder directly without finding the quotient. That too without actual division or by synthetic division. How? Let's see. So what is the definition of remainder theorem trying to say? If a polynomial f of x is divided by x minus a. So we have a polynomial which is getting divided by a binomial. The remainder is f of a. If a polynomial f of x is getting divided by x minus a, the remainder is f of a. Now those who have understood, fine, but those who have not understood, sir, what exactly the technicality or the language of remainder theorem speaks, let's understand by taking this particular example. What is it? To find the remainder, so we are not interested in finding the quotient, we are supposed to find out the remainder directly. To find the remainder when this is f of x, polynomial in x, when 6x square minus x minus 2 is divided by x plus 2. So when a polynomial f of x is divided by x minus a, what could be the remainder? Answer is f of a. Let me make you understand everything here by solving this particular sum. So we have a polynomial, right? F of x is getting divided by x plus 2, that is binomial. So my solution will be f of x is 6x square minus x minus 2. Now comes the major thing. Here the divisor is x plus 2. Now those who are wondering with the definition that f of x is divided by x minus a, the remainder turns out to be f of a. So how this minus a got converted to plus a? Here is the answer. Whatever is the divisor, we just need to equate that divisor with 0. Whatever is the divisor, we just need to equate that divisor with 0. So here the divisor is x plus 2, which implies therefore x plus 2 equals to 0, which implies x is nothing but minus 2. X is nothing but minus 2. How we had x minus a? The remainder is f of a with an opposite sign. So we had divisor as x plus 2. X is equals to minus 2. Immediately the question might arise right now. Sir, what if we have some kind of coefficient over here then again we are going to do the same thing, right? We have sums based on that also, which is coming in the next slide. We have sums based on that. But initially when we are starting off, this is what the divisor, we equated 0, x is equals to minus 2. Therefore, by remainder theorem, children, this is what I want my children to understand. Remainder is f of a means what? We just have to substitute wherever there is x. Wherever there is x, we have to substitute it by minus 2. That's what the remainder theorem says. Remainder is f of a. So f of minus 2, because the value of x is minus 2, is equals to 6 into x square, which is minus 2 square, minus x. This minus is the quotient itself. X is negative, minus 2. F of minus 2 is 6 into minus 2 square is 4, minus of minus plus 4, plus 2, I'm sorry, minus of minus is plus 2 and minus 2. F of minus 2 is nothing but plus 2 minus 2 gets cancels off. I'm left with 6 4s are 24. When I say f of minus 2, then remainder is f of a. F of minus 2 is nothing but my remainder. This is what my remainder is. F of minus 2 is my remainder. That's what the question wants to say. Once again I shall say, if a polynomial f of x is divided by x minus a, the remainder is f of a. So if this particular polynomial is getting divided by x plus 2, I'll go for x is equals to minus 2. Had this being here minus, I would have got plus. Just substitute that, whatever is the answer is your remainder. Therefore, we just write down, therefore the remainder is 24. Right, children? Did you get that? What is the meaning of remainder theorem? Remainder theorem will help you out to get the remainder directly without going for actual division or synthetic division. Right?